subtracting epsilon and adding 1. So this is then simply 1 over epsilon minus 1 is the exponent there. All right, so let's plug these things in. So we get our first order condition becomes then that 0 equals epsilon over epsilon minus 1 times xt. We can now put xt back in there. That's this sum 0 to 1 cti the power of epsilon minus 1 over epsilon, now to the power of 1 over epsilon minus 1 times this derivative. We've calculated that. That's epsilon minus 1 over epsilon times cti power of minus, sorry, I forgot the di here, 1 over epsilon minus lambda t times, what was it here? Write it down. I didn't. So dy/t d, oh no, I did, right there, yeah. pt pti. That cancels, and we can now recognize that if xt to the power of epsilon over epsilon minus 1 was equal to ct, right, that was our definition of the consumption basket, right, our wardrobe from equation 2. That's simply xt is all the term in the integral. So it's xt to the power of epsilon over epsilon minus 1 is equal to ct. So if it's equal to ct, then let me write this, run out of space. If xt to the power of epsilon over epsilon minus 1 is equal to ct, then xt then xt to the power of 1 over epsilon minus 1. Well, that's just the epsilonth root of this. Right? This is equal to xt epsilon over epsilon minus 1 to the power of 1 over epsilon. So we get 0 equals, solve this with ct to the power of 1 over epsilon, cti to the power of minus 1 over epsilon, minus lambda t pti. Okay, and we can now, right, you can notice that, well, if this holds for some good I in the interval 0, 1, it's going to hold for another good, say j, in the interval 0 to 1. Right, and we can equate then the, say here, the Lagrange multiplier for good I and good j, right? Lambda doesn't depend on, right? It depends on our total expenditures. It has to be equal to our total budget and our 10 million dong shopping spree to put together a wardrobe. And we can write this then when we combine it in the form of equation 6. And this gives us the whole insight for why this Dixit-Stiglitz, this aggregator, is useful. Equation 6 is our relative demand function. I would like to have as many pink shirts as blue shirts. Right? I have a preference for variety in my wardrobe, up to relative price differences. So it helps to think through a couple of examples with this, and sometimes a better way to write this, I think, what I'm following than what a lot of textbooks do. Let's write this then as CTI is equal to CTJ times, let's do PTJ over PTI to the power of epsilon. Because epsilon's a positive number, so minus epsilon is a negative number. Let's just flip that around so everything's positive. All right, so let's say PTJ is greater than PTI. Right? Good J is more expensive. Well, we know what's going to happen. We're going to buy less of the more expensive good. All right, so the consequence here, PTJ over PTI is greater than 1. Power of epsilon is also greater than 1. So our demand for good I is going to be the same as our demand for the good j times the number that's greater than 1. We will demand more of good j, we'll demand more of good I than good j if good j is more expensive. Right? We're going to demand more of the cheaper goods. But by how much? Well, it's going to depend on how easily we can substitute those two goods for each other. If I have this bottle of water costs, say, 10,000 dong, and this bottle of water costs 2,000 dong. Which are you going to buy? Two. They're identical. I'll buy the cheaper one. They are perfectly substitutable, right? Which they're the same. Perfectly substitutable. So I will demand all of my demand, right? Epsilon goes to infinity. For any small price differential, I will buy, my demand will switch entirely to the cheaper good. Entirely. Right? Or in other words here, if it's the other way around, right? So let's try. If PTJ is less expensive than PTI, right, then this ratio PTI is less than 1. It's less than 1, and as epsilon goes to infinity, then right, it's a fraction. It's some number between 0 and 1. So if it's 1/2, Right? To the power of 2 would be 1/4. To the power of 3 would be 1/8. To the power of 4 would be 1/16. To the power of infinity would be 0. Right, so for perfectly substitutable goods, our demand for the more expensive good is 0. We will buy nothing of the more expensive good if it's perfectly substitutable for a cheaper good. So this is getting us. This is going to give us the perfect market world, right? This Walrasian actioneer, right, doesn't have to, it's a limiting case here. If the goods are perfectly substitutable, then we're only going to buy the cheapest good and nothing of anything else. Give you a So this is me at the supermarket in Frankfurt. I like coffee. I've talked about coffee. I want to have a cup of coffee every day and not 30 cups of coffee on one day. Now, we can think about how substitutable these different types of coffee are. And you can look at the prices. So, right, so it's 8 euros for half a kilogram of ground coffee. Right. Is that expensive? Would that be 8 euros? That would be like what, 240,000 for half a kilo. Yeah, 240,000 dong for half a kilo. It's pretty similar. Tradable commodity, right? Because otherwise, I'd be filling my suitcase with coffee and going back home. I might buy some. Maybe the coffee is better. But now, I have to admit something. I like coffee. I drink coffee every day, but I'm not a connoisseur. I don't appreciate quality. I grew up in the middle of America where we would have like a restaurant, an American diner. They would have coffee from the day before that had just been held on a heating pad overnight. So there's some people, some of my friends, they liked it. It has to be an espresso macchiato with, I don't know, soy milk frappe with a I have no idea. Really complicated, like, right? It has to be the special beans and this and that. I have a colleague, he can only use these beans that have to be ground at the right size and twisted in to get the puck that does the. That's not who I am. I like coffee. I love coffee, but my coffee has to be hot, brown, bitter, and have caffeine. That's all I care about. So let's see. You're gonna buy coffee for me. Right, so you've now done some marketing. You know that the brand's up here, and perhaps down at the bottom, we have a cheaper, this is the generic brand. It's not a name. Ja is the name of the brand from one supermarket in Germany. And here, $3.99, right, is the cost of half a kilogram. There's, up here we had the Dallmayr promo, the $7.99, or Ethiopia, right? The African, maybe it's highland African coffee bean, or Mövenpick der Himmlische. Der Himmlische, that means the heavenly, right? 8 euros for the heavenly coffee. Or, do you notice there's a different color label on this coffee. This coffee was on sale. It was on sale for €4. And if you notice, that sale price of the Jacobs brand coffee was exactly equal to the price of the generic brand coffee. So, if you're someone where a very specific brand is important, right, I have to have Elis Gourmet coffee, then they would have spent $7.80. If you're like me, I would have bought the cheap generic brand coffee from the brand, Yes brand, right? But Jacobs coffee was on sale for $3.99, so I bought that. Right, so this is pretty, I think, standard behavior, but it depends on your elasticity. It's simply because my elasticity between coffee brands is very, very high. All I look at is the price. I can give you, I don't know, let me see. All right, so I'm American. What are we known for? We drink cola, right? And we have specific tastes for cola. Let me see if we can add in Fritz Cola, Afri Cola, Sina. In Germany, there are also other cola brands, like Afri Cola or Fritz Cola, or there's also Pepsi Cola and there's Coca-Cola. I prefer Coca-Cola. You can blindfold me, and I can taste which one is Coca-Cola. Not just between Cola Light, Diet Coke, or Cola Zero, and I can taste the difference between different brands of Coca-Cola. Right? That's how much Coca-Cola I've drunk in my life. Oh no, it's on camera. Huh? My substitution elasticity is pretty low. I will pay more for Coca-Cola than Pepsi. If they're the same price, I'm obviously going to buy Coca-Cola. If Coca-Cola is 50% more expensive, I will still buy Coca-Cola. If it's twice as much, I'll probably still buy Coca-Cola. My elasticity of substitution is a lot lower, certainly than my substitution of elasticity for coffee. Right? Is that right? Is that wrong? That doesn't matter. That's just my preference. Yeah? So we can think about, as individuals, we have different price elasticities for different goods. Yeah? Right? Now, we don't have, this isn't the elasticity between J and I, right? Or the elasticity between Pepsi and Coca-Cola, or between Ja brand coffee and Melita brand coffee. We just have one epsilon for the entire economy. Yeah? So it's really kind of like our average, remember our average substitutability? It's how much competition we have, how many different options we have is perhaps the way it looks at. So think again about abstracting from the micro to the macro. We can then take one of these, take it to 6, put it back into our expression for consumption and our budget constraint. We can pull out some individual good. Now we can use our definition of the price level, right? And we can determine that Z, right, our total expenditures is equal, by definition, to the sum over all the goods times the price that we buy, or is equal to the consumption basket times our price level. Yeah? So once we've determined optimal demand, right, and we're the representative household, then our total expenditures is equal to the sum of the purchase of all the individual goods times their individual prices, or the number of baskets we buy times the price of the basket. We've separated this consumption decision into two parts. First, putting together the basket, and now we can determine how many baskets do we want. Do you want the optimal wardrobe that allows you to go 1 week without washing your clothes, or 2 weeks without washing your clothes? Right? It would be the same wardrobe, just another one, right? Or a third one. So once we've determined the optimal wardrobe, we can now return to the household problem to figure out, well, how many wardrobes do we want? We've already got the optimal mix of socks and shoes and colors of shirts and pants and all of this. Now we just want to determine then how many wardrobes we want to buy. And we can now re-express this relative demand function into our optimal demand equation that also our firms are going to use. We're going to express things not relative to another good, but relative to the aggregate, relative to the average, relative to the basket and the price of the basket. So there will be an amount of good I in our basket equal to the average amount of any good. Remember, because we've got this indexed on 0, 1, the CT, our basket, is essentially telling us how much we have on average of any good. Yeah? So our demand for good I will be equal to the average demand for a good if the price of good I is equal to the average price of a good. Right? If good I is more expensive than average, this will be greater than 1 to a negative power. It'll be a fraction less than 1. We'll demand less of this good, and vice versa. Right? So you can take this logic here for between goods and now express it relative to the basket and the price of the basket, or aggregate consumption and the price level. Right, and this is going to be important for our firms. They're not going to, remember, they're atomistically small. They're not going to consider, when they change their price I, how this might change C or P, because they're infinitesimally small. They're not going to be able to change to affect the aggregate price level or our total demand. But they will take into account that if they raise their prices, we'll demand less of their goods. Right? But by how much is going to depend on our substitution elasticity. Think of, with an Apple good, right? You have the Apple share. What's that called? The AirDrop. You have what's Apple Drive, or what's the cloud solution for Apple? What's that? iCloud, AirDrop. And so my family's always complaining when we do something. They're all on Apple and they can share things and albums and this and that. And then, oh yeah, Dad, you're an Android, you can't see our stuff. Yeah? What am I saying? That Apple knows that the substitutability is lower. I mean, this, in terms of the actual content in here, these are transistors, and it looks just as good as an iPhone, if you ask me. Yeah? But the substitutability is perhaps lower. What does that mean? If the substitutability is lower, then Apple can charge a higher price than they otherwise would be able to if the substitutability was higher. Because the substitutability is lower, it's difficult for us to switch to a different good. With a high elasticity, that's me buying coffee. The price is higher, I'm going to switch to a different coffee. With a low elasticity, that's me with Coca-Cola. If the price is higher, I'm still not switching away. Yeah? The firm knows this and is, of course, going to use this information when it decides on its prices that we're going to get to in a bit here. All right, now the maximization for the household is then straightforward. We have an intertemporal optimization problem. All right, so the derivative with respect to CT, we now have, maybe I should write that. Yeah. So I'm going to write it out the long, hard way. And this will help you see why we write it this way and what we're going to do with this E0. So at any given point in time, at time t, all right, well, first maybe I should define this. This is some epsilon t of x, I'm going to call it t plus s, is equal to the mathematical or statistical, the best predictor of x t plus s with all information in our information set it. And you could think of it, or what do we have in it? We have maybe the all like past observations of x, all shocks. Maybe we have like zt as a shock. All right, every variable, and since we'll also include xt. Yeah. So all current and past realizations of variables are in the information set at time t. Right, and this is, I mean, this seems a lot. I mean, we when we're making a decision, we know what's happened in the past, we know what's going on now, but we don't know the future. Right? There are actually a lot of economic theories that say that this is difficult. Like we can't know everything, even know everything from the past. Right? We have some inability to process everything. And there are also some things that are there's a personal question. Does anybody have any cash with them? Yeah? Is a dong and cash? Right, so like currency, yeah? Do you know exactly how much? Yeah. Exactly. Yeah? Oh wow, okay, I'm impressed. Most people don't know exactly what they have, right? I think I have like about 50,000 dong maybe, or maybe I have something maybe close to 80,000, but they're not, maybe there's 1,000 extra, 1,000 less, right? Or do you have, if you have a bank account, do you know how much money you have exactly without pulling up your app and looking at it? Right? Yes, you do. Wow. So we have a true economist here. But it's funny, most people don't know this information. Wow.
I just have a little, so I remember.
Okay, so then you remember, but most people usually have a hard time keeping track of exactly this number. Yeah? We all it's the most important number to know in making our decisions, but most of the time people know this number maybe, just roughly. Yeah? So even this, some economists would say is certainly assuming too much. We frequently don't even know how much money we have in our pocket, which should be the most important decision or the most important information for making an economic decision. But in any case, this assumption means that everybody in the economy, or anyone who's forming an expectation, conditional on this information set at time t, where the information set is everything from now in the past. Yeah? There's no misunderstanding about the past, there's no misunderstanding about today, but the important thing is that we're imposing that they can't see into the future. They don't know what happened at xt plus 1 or the shock tomorrow. We're making our decisions simply based on what we see today and have seen in the past. Yeah? Just be a conditional expectation. Right, and we'll also have no, that's fine for us now. So at time t, right, the way the problem is written here, we're starting at t equals 0.